Simulation mode is a very powerful tool that allows users to decouple their project from physical hardware. If you're collaborating with a group of engineers and they don't have the same hardware configuration as you do, or maybe they don't have a pack at all, you can still continue to work with them and you can review each other's code. If you're on the road or you work remotely a lot, you can develop and debug your code without being tied to a test bench. Since Parker Automation Manager is free and available online, there's also no upfront commitment to hardware. You just want to try out our software and you're not ready to commit to the pack? No worries. You can review all of its features, including PLC programming, motion control, and web visualization. Let's say that I was sent this feed and cut demo from one of my colleagues and they wanted me to review their code, but I've never seen it before. I can immediately see under the ethercat_master the hardware that they had associated with it. Let's just say I'm on the road and I don't have the ability to sit down and collect all of this hardware. So to get this project in simulation mode, I'm going to go up to Device, right-click, and select Simulation. In the lower bar, you'll see that I am now currently in simulation mode. If I double-click on the device and go to the communication settings, I see that I don't have the option of connecting to anything. In fact, both the gateway and the PLC say simulation mode. In order to get this application running, I'm going to log in and download just as if I had a physical device. I'm going to select yes. So what Automation Manager is doing here, it's actually compiling and downloading the project into an emulator that's running on my PC. Once it's done downloading, it defaults to being in stopped mode. In order to get my application to start running, I need to hit Start or F5. The way that the programmer has set up these folders and their naming scheme, I'm pretty sure that they want me to start with the main_state machine. So let's go ahead and open it up. I'm currently in the initialization state, and I am waiting for GVL.B access ready to toggle high in order to go into standby mode. But since I'm not really familiar with this code, I don't know what B access ready is. So what I can do is I can right-click, browse, and browse to cross-reference. Now a lower panel will open and it will tell me everywhere that this GVL.BAccessReady is used. I can see where it's declared, where it's read, and where it's written to. So I'm most interested in where it's actually being written to. So I'm going to go here to the power drives_PRG. If I double click it, it'll automatically take me to where the GVL.BAccessReady is written to. I can see here that they chose to use CFC or continuous function chart. That's a great language for this purpose, for use in what I like to call a maintenance layer, or where I'm trying to communicate how the machine operates at a very high level so that someone, for instance in my situation, can easily understand what the programmer was intending to do. So on the left-hand side, I have all of my inputs. I see that I have an axis 0 and an axis 1. My enable for this function block is true, so my only other input option is X enable drives. So clearly I'm going to need to toggle that variable in order to power my drives and indicate that my axis is ready to move to the standby state. Since my cross-reference list is already open, I can just simply click the variable X enable drives. I can see here that they are declared within my pack IO module. It's automatically going to take us to the EtherCAT IO mapping where X enable drives is declared. We can see that it is mapped to digital input 0. Well, we're using simulation mode, so I can't physically toggle a switch, but you'll notice that there's a prepared value column here at the right. I can simply click true and either can go to either debug, write value, or I can press Control F7. So now my X enabled drives is true. If I go back to my power drives, I can see that my X enabled drives is now true. And if I go back to my state machine, I am now currently in standby mode. So you can see already how easy it is to follow this code and how easy Parker Automation Manager makes it to follow the code while it's in run mode, because it actually reads the current values, and the way that it highlights the visual languages makes it very clear where you currently are in the code and what the status of the pack is. So moving forward, we have our next set of transitions. It looks like I have 3 options of what can potentially occur here. So we have a transition that is called the feed and cut entry_trans, not GVL.BAccessReady. So if I toggled my quote-unquote input 0 off again, we would jump back to the initialization state, or I have this jog mode entry_transition. I'm going to try to get to feed and cut state because I think that's probably the most interesting motion profile. I don't know what this feed and cut entry_trans is, so I'm going to go ahead and click it. So if I double click, it'll take me to the feed and cut_trans. Again, whoever programmed this, we have to thank a lot because they're using another very easy to read language. Of course, I'm sure you're familiar with ladder diagram. So I see that I have an HMI.B run cycle that I want to be true. However, I want to make sure that my HMI.B jog mode remains false. Clearly, there is some HMI that is associated with this program that I haven't taken a look at yet. And we know that because the programmer has made it very clear because they've declared their variable list as HMI dot. However, if I wasn't quite sure or if it was a very complicated HMI, I still might not know exactly what they're trying to get me to do. So again, I'm just going to click the cross-reference and I'm going to see that it's used in the main underscore viz. So I'm going to go ahead and double click it and it opens my main viz. Now I'm going to move these windows a little bit because I want to see my main viz HMI on top of my state machine just because predominantly I think it'll look cool. So I can now go ahead and hit run cycle and boom, I get into my feed and cut state. I'm going to go ahead and just to show the power of simulation mode, I'm going to open up the feed and cut underscore PRG. So even though I don't have any actual physical drives here, I can still follow the motion code as if there were drives on my system. Of course, these drives are going to be perfect with no error, but nonetheless, it's close enough to get me to continue to debug and develop my code. I hope you've enjoyed this brief walkthrough of simulation mode, and I hope this will inspire you to download Parker Automation Manager and try the feed and cut demo yourself.